Hello, my name is Aaron Johnson. I'm the owner and operator of Red Dot Consulting LLC here in Anchorage. I specialize in public key infrastructure in the cybersecurity realm, and this video is gauged towards the IoT crowd, trying to look at using certificates for both server and client authentication. We're going to be using a hypervisor called VMware Workstation Pro and a server with the Ubuntu desktop version, so we can get that GUI, and the XCA component. I'm going to be testing against my lab, which is running a Windows Enterprise package of Server 2016 and Active Directory, so we can utilize accounts that are stored in Active Directory and the DNS that is already established to save time. So let's get started. So here we're on VMware Workstation Pro. I'm going to use the highest compatibility level for the hardware, the Ubuntu desktop version for that GUI. Our user is going to be Tony Danzarific. Username Tony, password 123. Password 123. I'll move this over to the repo that I would like to use for this. And we'll call this hack root CA. Processor is fine at 1, and we'll bump it up to 4 gigs of RAM. We'll add the NIC after the wizard gets through here. New virtual disk as a single file with 20 gigabytes of space. Name is fine. Add the NIC. VMnet 2 allows me to get layer 3 on my lab network. That's it. Ubuntu is configured. Let's give it some network. Go to static IP address. And a public IP address for the DNS server. So it's public DNS. Looks like it took. So what we can do next is start adding our dependencies. Okay, so first update with apt-get. While this is working, we're going to go ahead and add Samba, Apache 2, and XCA. These are the 3 packages we'll be utilizing. Let's configure Samba before we go any further. Samba utilizes a different set of passwords than the Linux box. Password 123. Let's add our folder we're going to share. Put it in Tony's home. Search stuff's a good name. Copy the original Samba config file in case we have to revert. let's open up the file and configure it. All we have to do is add at the very bottom of the file the folder, path, the valid user, and that it's not read-only. Save it. We'll verify. It's there. Now let's reload Samba. Okay, let's add Apache. This part is the most scripted piece to this demonstration, so I apologize for the speed of this. Let's write a web config. And what we want to do is add some features to it. I want to verify that there's nothing above. So we're going to allow directory browse and allow double escaping. This will allow folks to see what's in the curl distribution point, which is what we're setting up, as well as allow characters such as the plus sign to live here if you were to introduce a delta krill file. Verify, looks good. Now let's add some configurations to Samba itself. Okay, copy the original for our site, and let's tweak it. We're going to remove the document root pointing to HTML, and the reason is we want folks to have to browse to the PKI folder, and that allows you to expand on the use of this krill distribution point should you choose. And since we wrote it, I just want to verify. Okay, looks good. Now let's go ahead and register the site. Add some permissions. We should do this in the location rather. I'm going to copy and paste. So we're going to allow Tony to be the owner, the group. Oh, that didn't work. Sorry about those beeps. I'll try not to do that anymore. chmod to 750 for the folder. Chmod g+s for the folder PKI. Let's list what we did. That looks great. PKI has Tony as the owner, www-data is the group. Almost ready. Let's punch some holes in the firewall. Samba. Apache. And reload the service. Do a little test. There's our web config file that we just created and the site. So we're done with our krill distribution point. This will be the website we use to verify certificates, as long as the clients can reach it. Since we're not using DNS, we're going to use IP addressing. Now, let's get XCA. This is an older version that's available in the Ubuntu repository, but it's already compiled and it is suitable for our needs. Let's get rid of some of this junk that came in. And add our new package XCA to our list of favorites. Let's go ahead, add a folder for our XCA database. This is living in our documents folder, so it retains a permission set for Tony. Tony's going to be the only user. And let's pop it open. Now, new database. In that folder we just created, let's call this Hackathon. It's going to ask for a password, very important to remember this. It's password 123. And what that does is it allows encryption of the private keys that are stored in this database. We are not using any hardware security modules on this, which is what you really want if you need to provide that protection for your private keys. Make the screen nice and big. Now the next step here is we're going to throw in some templates, and we'll do that right now. So here we have XCA open. We'll do a tour in a second. We'll do a tour as we get these templates in. Let's get them added. Alright, let's have a look. So this is the template we're going to use to create our root CA. Some things to note on here. So we are adding a krill distribution point. Since this is a single server, single tier PKI, we should stamp a krill distribution point. That's what we just stood up. And the reason is this will allow issued certs something to check against. So anyone that consumes the issued certs we issue will have a krill distribution point to verify against. The next field on here is called Authority Information Access, and this provides a site that folks can go and grab the root CA cert, including browsers if they don't have it. Key usage, we're going to use digital signature, certificate sign, and krill. That's what we are doing as a root CA. This Netscape tab is legacy, but we'll just create a comment on here so we can track the use of the cert as we go through the demo. Basic constraints. This is a critical flag, what that means is any operating system or application that can't parse out what's being offered or what's being shown here on the certificate that's marked critical should stop using the certificate. So be careful what you set critical, but basic constraints is always set as critical. This case is a CA, a certificate authority, and that's basically the role of this field here to indicate whether it's a certificate authority and how long the tree is going to be. In this case, we could just put 1. We're going to leave it alone. The other thing to note is subject key identifier. That is ticked. That's very important to tick at the top of your root trust here. That allows chaining engines to track different certs for this and chain them together a little bit easier. So that's about it. Let's go ahead and create our cert. So we go to the certificate tab. Actually, let's just go right off of that template we just created, right click and hit create certificate. Let's apply all those extensions we worked hard to populate. We're going to create a self-sign with a serial number 1, and let's give it a name. Hackathon root CA. Hackathon root CA 1. Now, internal name, that can often be described as a friendly name. Doesn't get stamped on the certificate, but is a way to track where that cert is in your database. Okay, let's generate our private key. Bump this up to 4096. Let's use the same name as our common name. So that's in the database. You can certainly choose to add this to HSM by using PKCS 11 with XCA and throwing the provider and telling XCA where to look for that provider. CRT and CRL, that looks good. 10 years, fine. Everything else is fine. And our distinguished name has all these fields that we should include. Okay, IT, organization name, hackathon, we're good to go. So we have our certificate right here. Let's generate our empty krill. I usually use krills for 7 days with 2 or 3 days overlap to allow folks to get back in the office should stuff break. And well, that's fine. Alright, so now what we need to do is pump these into our krill distribution point and our share. So we'll do that next. So here's the certificate we just created. Let's export it. We're going to match the name that's stamped onto the certificates for our krill distribution point and our AIA. In this case, this will be referenced by the AIA. Saw that it already existed. I gave it a test run before this. So what we're going to do is file name, cert stuff, that's our SMB share, that looks good. But we do want to make sure that it's being saved as a krill and match the name root.ca. That's going to save us some time of renaming the file after the fact. And again, we'll do it. So let's go over to our folder here, copy these. I usually pull them off of the box to verify. So here's the krill. This Windows client is parsing it just fine, and the cert. So we are good to go. Now what we need to do is copy these to our root distribution point. Or, I'm sorry, our krill distribution point. Sorry about that. And do the same thing for the cert. And let's check to see that our website has it. Looks good. Okay, So that's fine. We can move forward. So the next step is going to be creating some certificates to consume. The first one we're going to look at is our web server, including with the SAN field. Very important to include that, and ultimately culminating in a client auth cert, so you can use that to get into this website. So let's get cracking on that. So go back to our templates. Here's our SSL template that we imported. Let's have a look at this. We're going to leave it right there, I guess. Okay, so common name sslsite.reddogconsulting.us. So now we're going to use DNS to find this site. And this is important because the name should match, and IP addressing, using that as common names, is generally frowned upon. And it does lock you into a bit of a box. But there are cases where that can be used, such as routers, etc., etc. Okay, one thing on here, krill. Here's a mistake on the template. We got to reference our AIA, which is a cert, not a krill. Key usage, digital signature, key encipherment, and our EKU of web server authentication. We'll leave Netscape out of this picture. And alright, so there's our template. Let's issue a certificate off of this template. First thing we want to check is that it's chaining to the cert we just created. Apply all the extensions from the template. We can check. We'll copy this to the internal name. Highlight this, hit generate new key. That populates the name appropriately so we can find it in the database. So this is stored in the database. The extension, okay, so the common name is right here. Let's copy it because we have to add it to our subject alternative name field so that we can pass browsers. We want to change from URI to DNS, and there we go. That's it. That's all we have to do for this certificate. It's fine to tick these. It'll just help chaining. And we'll just go through, click all the boxes real fast, maddeningly so for you watching it away. Apologize for that. And we're chaining SHA-256. Okay, let's create that cert. Okay, so now this is what's good about the GUI here. We can see how it's chained up to the original cert, the Hackathon root CA. So let's export that. We're going to export this as a PKCS12 file. This includes a private key. And this is going to save us from generating a certificate signing request. We'll password protect it so that anyone were to get in with Tony to our share, they wouldn't be able to use a cert without that password. So here we go. Looks good. And let's go find it. There it is. Okay. So now let's go back and plug this into a server. Okay, so here we are on a client box. It is a Windows. I am going to speed up the demo by using Windows IIS server for our website and other testing purposes. Let's go over to our share and grab the PFX file. The reason why this went right through is because the password was already cached from a previous attempt. So let's grab this. And let's install it. Actually, one thing before we do, let's grab our root CA as well. Okay, we're going to install this certificate before we mess around with our chain that we just created, and that will avoid any of the errors that you'd see once you import it. That looks good. Okay, now let's import our new cert. Current user is not okay for this. We're going to do local machine. That's the file. Here's the password we got to plug in. We'll automatically select the store that these certs in the chain can go into. And let's check. So it's showing as valid, and what we want to make sure is that these fields that we plugged in, common name matches our subject alternative name, and we can use it with our IIS instance. So let's pop that up. I already had a 443 binding on here. Let's just add that cert. And let's go and test it. Well, you'll see here it's asking for a certificate. Well, that's something that we are going to configure here, but I jumped the gun. So let's turn that feature off. Right here we'll require SSL but ignore client certs for the time being. One other thing while I'm here, and you'll see this in reverse phase here, but I have to allow anonymous in so that we don't have to prevent authentication yet, because we don't need to do that. So there we go. Hello SSL site. That shows us that we are accessing the SSL site using the cert we just created. Here's the cert, here's the chain, and the valid from 403, so it just issued a couple minutes ago. So we know it's the one that we just created. So that is our server auth cert. Let's move to a client auth cert. So for client auth cert, we're back onto our XCA. Here's the template that we created. We need one for our client auth. Okay, so let's preset it with here. Actually, let's do this. Let's duplicate, rename, client SSL site, and let's change this so that it makes sense. Common name is not going to be applicable here, so we need the new one. Test user at reddogconsulting.us. Okay, so now go over to extensions. That looks good. Krill insert. Mistakes that we made previously weren't on here. Key usage, switch to client only. One note about this, try and limit the issued certs to just the purpose of serving. If you go a little bit too heavy on what you're going to allow, it could be a challenge with security down the line. Everything looks really good. I don't see my SAN field, so we got to populate that. Okay, so we're going to add, since this is client auth, we're going to add the email address, not DNS, and that looks good. So here's our test user that's available in Active Directory. Key usage checks. Yep. Extensions are there. We got SKI is fine. Email is there. Common name should match. Yep, we know it does because we copied it. And it is using a client auth EKU, extended key usage, and so we're good. So let's issue a cert off of it. Apply everything. Again, you usually wouldn't go as far as to populate the common name on a template, but since we're just creating this one, it's fine for this example. Create a new key. This is a private key. Bump it up 4096. We're looking real good there. Make sure that you're using that original cert to sign this thing so that it chains. Extensions again, key usage again, Netscape again, and advanced. SAN. Okay. So you see me verifying a lot on this. Well, the bummer about certificates, and it's actually a good thing, it's by design, but once you issue it, it's stamped and you can't change it. You have to reissue. So that's why I keep checking. So here we go. Let's create the cert. Nice and easy. Let's export it again as a PFX. In this case, we'll call it PKCS number 12. That's a standard. Looks real good. Password protect this. Okay, so at the next video, the next section here, we're going to look at configuring the IIS server to do client certificate mapping. Here we are back on our IIS server. Let's reset all those values that we turned off previously. So we're going to disable anonymous authentication. And I already have the modules for client certificate mapping. We're not using the IIS version, we're using the Active Directory. And here it is. Once you enable this, this also does another thing by enabling the DS mapper for that. Windows Server 2016 moved a lot of this functionality outside of IIS and into the registry. I think I got the command wrong. Let me just double check. Okay, so the configurations for this is a little bit outside of what we are going to show for this demo, but let's have a look at something here. So if you cd into this folder, you can use appcommand.exe, and what we would just do is run the command to the default website, where we are going to set the config for the default website section is we're specifically looking for client certificate mapping authentication enabled as true, and then commit to this app host so it sticks. And that's the first command. We're not going to run it, it's already been run, but I wanted to show you the steps to enable this feature. Once you add the prereq for the role, here's the other command. SSL negotiate cert, that's actually turned off on the DS mapper, and that's fine. You can still set up your connection that's fully encrypted using the server authentication certificate, then submit your client auth cert through that encrypted communication. So those are the two commands you should run to enable the client certificate mapping. And then the last step here is we're going to provide Active Directory with a record of this mapping. So what we'll do is go to our client workstation. We're going to auth in as test user. That's the test user that we created the 1 minute. That's the test user that we created the account for. I usually disable them promptly. So let's go into our SMB share and grab those files. Before we do this, let's do a little cleanup. Get rid of any certs in here that will confuse the issue. So here's the other one, and here is another cert that we created previously, and I'll show you how that works. Basically that's to a non-existent user. So let's grab the files. Here we go. Right click and install PFX. Just as we did previously, we actually do need to do one more thing, and you guessed it, we gotta grab this XCA. Now, adding this to your store, you gotta do this in the computer store, so you have to actually run this as an administrator account. And we'll import that trusted root certificate authority certificate. Here's one from a previous go at this video, so let's import the one that's valid. Since since we're using this in a different context, let's go to test user, the desktop, root CA. Looks good. Alright, so now we can import our PFX, including the private key, and we'll let the wizard populate it appropriately. So let's check back to Cert Manager, and actually it's already open, so we'll just refresh. There it is. Let's see if it's valid. Good, this box trusts it. Details are good. So while we have it open, let's copy to a file, because we are going to provide Active Directory with a name mapping here. So we're going to use base64. I'm going to throw it in desktop, new client cert, new client cert. I got a little happy with the buttons, and let's go grab it. We are going to now put this on a domain controller, same one we were using before. So use our test user. We'll move that file over to a place that we can track. Temp file, temp folder. Right click, name mappings, get rid of the one that I did previous, and add this new one. So let's look at it. Common name, perfect. IT, perfect. Red Dot Consulting, LLC, perfect. Everything looks good. We're going to use the issuer for alternate security identity and subject for alternate security identity. That's way overkill, but I wanted to show you options here. Alright, so we got our name mapping in place. Let's do one thing before we go on. Let's create a cert for a user that doesn't exist so we can see it fail. Create certificate. Make this nice and big so you all can see it. We'll still make it valid. It's going to chain up, but we're going to change some things here. Call this Frank. It's a user that doesn't exist. Create a new key. If you highlight this and hit that tab, that name populates through. Key is created. Now let's add some extensions. Super nice, it allows you to edit. That's pretty cool. Frank, extensions, krill and assert, key usage, client auth. Everything looks good. SAN is there, and common name will be there once we create the cert. It's chaining to the cert. Alright, we're good to go. Here is Frank. Let's export that. Again, we're going to use the same format, P12, or the PCS 12. Windows sees it as PFX. And let's grab it. So I didn't change the location it was previously, so we should be able to grab it from our share. Here's Frank. Let's install it. And let's check our cert manager. Okay, looks really good. So now let's just do a real quick review of what we did. We created a valid cert that we're going to use to client auth in, invalid one, hopefully proving that that it doesn't work. It won't work. This is fine. They both have private keys because we used a PFX format. Very important. Try not to store any non-complete certificates in your personal store here unless you need to for a specific reason. It just gets a little messy. These are from smart cards, but anyway. And our trusted root is here, Hackathon root CA1. I'm going to get rid of the previous attempt here. Okay, looking good. Just making sure I didn't delete the wrong one. Hackathon root CA1. Okay, we're good. So let's give it a test. So on our test, we have to kind of set up the website, the web server appropriately. So make sure that anonymous authentication is disabled. Let's go into SSL settings and tick the require client certificates. Okay, that's the only feature that's going to work on this demo. So just to go back, we can even pull out a binding here of 443 if you want. I'm sorry, pull out the binding of 80 so that your clients have to go to the 443 binding. And let's test. So here's our client box. Here's our test site, sslsite.reddogconsulting.us/test.html. You're going to see that wheel spin. That's a good indicator because it could be a hidden box here. So let's show success first. Here's the valid cert. Here is the content that we have on the site. Hello SSL site. So we're in and we have full encryption. Now let's test with our invalid certificate. And the wheel is spinning, so let's go back to the hidden window and let's pop open this frank that doesn't map to anyone, and we see unauthorized. So in short, let's recap. We spun up a single server, single tier PKI using free utilities. We tested against Active Directory IIS, but just to go back to what we're actually looking at here, which is IoT, there is no problem with skipping a couple of things here for your hackathon should you choose to use certificates, because you don't have to do name mappings to make this valid. It's great if you want to take the time to do that. It's going to just scale out as far as it can, but just sometimes adding the config to your web server to require client auth certificates as well, so that's called mutual SSL, as well as populating the trust store with your certificate authority will get folks in. I am trying to make a habit of showing some of the more advanced features just to stir some thoughts on people, and that's what we've done here. So I hope you found some value in this. I'll put the links to some of these scripts in the description field, and good luck with your hackathon. And again, my name is Aaron Johnson, Red Dog Consulting LLC out of Anchorage. Thank you.